this video, we'll look at this inner product space, P2, so polynomials of degree 2, 1, or 0, with this integral inner product. I want to show that these two polynomials are orthogonal with this inner product, and then I want to find the angle between these two. So let's do A first. A is faster, because to prove they're orthogonal, I just have to check that their inner product is 0. So let's look at PQ. That'll be the integral from -1 to 1 of P of x times Q of x. So x3, I get x4 over 4. I'm going to plug in 1 and -1. At 1, I get 1/4. At -1, I get 1/4. I get 0. As soon as the inner product gives you 0, that tells you the angle is 90, and so P is perpendicular to Q. Alright, let's now find the angle between these two. To find the angle, I need to find the inner product of the two, but I also need to find the length of P and the length of Q, so it's a bit more work. So let's start with PQ. In this case, we have x squared plus 1 and x plus 2. So I want to multiply them out. I get x cubed plus 2x squared plus x plus 2. Alright, so that's x4 on 4 plus 2x cubed on 3 plus x squared on 2 plus 2x, in which I'll plug -1 and 1. So at 1 I get 1/4 plus 2/3 plus 1/2 plus 2. At -1 I'll get 1/4 minus 2/3 plus 1/2 minus 2. So the fourths are going to cancel, the halves are going to cancel, and I'll get 4/3 plus 4, so that's 12, I get 16/3. At this point, we don't know the angle. We know it's not 90, and since it's positive, it's going to have a positive cosine. So from 0 to 90, it's going to be an acute angle. To know actually which one, I need to check the size of P and Q. So I'm going to have to compute the inner product of P with itself. So I'm going to get -1 to 1 of x squared plus 1 squared. So that's -1 to 1, x squared plus x4 plus 2x squared plus 1. I'll get x5 on 5 plus 2x cubed on 3 plus x -1, 1. I get 1/5 plus 2/3 plus 1 minus 1/5 minus 2/3 minus 1. So I get 2/5. I get 2/5 plus 4/3 plus 2. So that's over 15. I'm going to get 6 plus 20 plus 30. I get 56 over 50. Alright, so that tells me what the length of P is. The length of P is square root of 56 over 15. Now I've already computed the inner product of Q with Q, so let me just give it to you. So that's the integral from -1 to 1 of x plus 2 squared, and I got 26 over a third, so that means the length of Q is square root of 26 on 3. And so now I can put them all together. So theta would be arc cos of PQ, length of P, length of Q. We've already computed all of these, so let's just place them together. We got 16 thirds over square root of 56 thirds, 26 thirds. Which I put in a computer and I got about 20 degrees. The angle you get depends on the inner product. There's nothing intrinsic about polynomials where their angles are. It depends on the inner product. If you choose a different inner product on P2, you'll get a different. In fact, the lengths will depend on the inner product. Which vectors or which elements are orthogonal will depend on the inner product. And just to show you, prove that to you, I'm going to use a different inner product. One that we didn't look at, but we looked at it for P3. So let's look at an example. I'm going to use the same one we just looked at. So P is x and Q is x squared. And we proved that these were orthogonal with the integral inner product. I want to prove that they're not orthogonal in P2 with inner product PQ. We had the evaluation one. We checked all the condition. We're going to use it on P2. For P2, I'm going to need 3 points. So let's make our lives as easy as possible. Let's use P minus 1. Oh, actually, does that work? Let's put a tube here. Alright, so let's check what is our PQ. In this case, I'm going to get minus 1 times 1 plus 0 plus 2 times 4. I'm going to get 7, which is not 0, so P and Q